Cool. So welcome everybody to the second event of DSC Delft for 2021 or 2020, 2021. We've had a great intro and some good feedback from you guys. And we've whipped up the new event for you. Today is going to be about systems programming. So that's everything about like low-level languages and well, relatively low-level languages, and the types of languages you might want to program systems with, as the title suggests. So first of all, I would like to, if possible, I know it's the evening and all, but if possible, I would like to get as many of you guys to turn on your camera, just so we could feel like we're actually in a physical meeting, which is what we have been doing, last year. This is a chill session. You're not gonna be recorded or anything, because only it is being recorded, but just the presentation itself. So if you would like to turn your camera on, that'd be cool. All right, thanks guys. And then Kuan, are you ready for like a bit of a group picture?
Sure.
Yeah, wonderful. All right, so let's do a bit of a wave at the camera so we can like see how many of you are here. Hey.
Hey.
Nice seeing you here. Cool. All right, wonderful. Thank you guys. All right. Let's get into the event now. So the agenda will consist of an introduction, which I've already done actually. Then I'm going to give you a few updates regarding the club, and a bit of information about upcoming events and also the solution challenge. Then we'll have the first talk by Robin about the quirks of C, which is going to be interesting. And we'll have a 5-minute break just to perhaps get a cup of water or go to the toilet. And then we'll get right back to it with a talk about Rust by Hector, which is also going to be very intriguing because it's an interesting language. All right, let's start. So I'm going to, first of all, update you guys with some of the upcoming events that are brewing at the moment. We've got a graphics event that may be an event, or it also may be a workshop, which workshops have seen very high levels of support in our polls, and we would probably have some sort of a target, perhaps an artistic workshop where you could set up an OpenGL pipeline by yourself and make some sort of a scene, perhaps. And then we're also planning a sysadmin or DevOps event. So if you're interested in like server management, you might want to tune in for that. It may feature Ansible by Red Hat. It may feature Kubernetes or Docker or containerization. Depends. Then we'll have a Svelte event, which is a super new framework, and it is exciting for some people. And we're confirmed to have live coding. We'll do like a super fast a dashboard and something in Svelte, which should be pretty cool. Then we're also planning a serverless event, and we'll have a very senior Amazon Web Services person who would like to introduce the Lambda portion of Amazon Web Services to you, which if you haven't tried using serverless architectures, it should be super interesting for you, because it's a completely new like headspace. And then we're also planning a collaborative roadmap event where you could set essentially goals and form little groups and accomplish those goals. So for example, to make a portfolio project, or to make something, or just for learning essentially. I'm going to try to get those going, because that was also a requested feature of our the club. All right, so if you're interested in any of what I just said, you might want to join the WhatsApp group, for which there's a QR code, and also I've put a link this time below. So if you can scan it, just input the link and you'll get the invite as well. We post news and updates in there mainly, so you won't get much spam. It's not a random group. And then also, if you're interested just to check for events by yourself, you can go to dsc.community.dev and look up Delft, the city, and you will be able to RSVP to all of the future events. I'll get reminders so you don't forget, which is super cool. And then on socials, you can follow us on Twitter, Instagram, Facebook as well, /DSC Delft. And then Discord, if you're interested in doing perhaps game nights, which we've done, we will be doing more of them. But it is an event where you basically can hang out with the community and relax a little bit and play a few, casual games. And yeah, and if you want to chat or like ask questions, that's probably the best place, because we can just respond and make threads and stuff, which it's not as nice in WhatsApp. Okay, cool. So the solution challenge, this is something that is an initiative from Google, and you may be interested in this if you want to get some airtime with them. If you make an exceptionally good solution, you will be able to present it in front of a lot of people, I guess, in a demo day, and you'll basically get a whole lot of approval from Google, which is pretty good. And the thing that is difficult about the solution challenge in these times is that it requires groups. So you need to have a team to make some sort of a product. And the issue with that is that you can't accurately form good, teams. So we're gonna try to get them started, or help you get those teams in the roadmap event, which is gonna be happening soon. And hopefully within the other workshops, like if there's something, if we can do something that like a workshop that you can do in groups, that would be great also for this. So we'll try our best, and hopefully we can start some groups for you guys. And this whole thing starts in January, so it's around the corner. It's not half a year away anymore. And yeah, more updates along the line. Okay, so let's start with the talks now. I'm gonna hand over now to Robin Martijn, who is gonna introduce us into the world of the quirks of C. Wow. Take it away. And be sure to unmute yourself. At the toolbar somewhere.
Super, thank you, Matt.
Wonderful.
Thank you. Welcome, everyone. I hope I'm easy to understand, but we'll try. Yeah, I've been asked to give a brief talk about the quirks of C, and I've been asked to keep it accessible. So what we're going to do today is meant to be understood by everyone. We're not going too in-depth, and we're also not going too specific into the quirks. We're just going to look at some of the possibilities that C offers, or actually used to offer, which are now a bit outdated, but still interesting to play around with. So a brief introduction about myself. I'm Robin Martijn, and I'm currently studying computer science and engineering at the Rotterdam University of Applied Sciences. I'm in the third year now, and I'm also the chairman of the study association there. So those are the things I'm doing right now. And besides the normal programming that I do, I also have a fairly big interest in low-level programming. And C is one of the languages that interest me most. And I also blog about that. The two examples we're going to look at today are examples that I use from my blog. So everything can be read later, and there are also more posts if you're interested in what we're doing. So let's jump right in. Most of my subjects are questions from someone. And the first one we're going to handle is a question I encountered on CodeGolf, which is a website meant for challenges in which you have to use as the smallest amount of bytes possible to solve a challenge. So in this case, someone asked to make a program or a function which waits for 1,000 years with an error of less than 10%. So this was a question asked on CodeGolf, and we'll jump right into the answer, which is this one. Fairly impressive, if you ask me. But the question is, why does it work and what does it actually do? So it lets you sleep for approximately 1,000 years. It's actually 952, if I'm not mistaken. So let's see why this works. And the first thing we do is format this line of code, of course, and we'll come to this. So what do we have? We have a declaration of I in the first line, and then we have a function declaration. And in the function declaration, we see two smaller functions, so to say. So let's start. What happens here? Normally, if you work in C, for the people who are not familiar with C, you give it at least an declaration. So what are we dealing with? An integer, a character, something like that. And also it has to have a value. Everything that does not have value is undefined. That's normally how we work with C. So why is this a possibility? Well, that has to do with C standard as it was written a few years ago. With a few years ago, we mean 1980 approximately, when these rules were put into life. So let's start with the first rule. And what we see when we look into the C standard is that every arithmetic type is initialized to 0, positive or unsigned, in our case positive. This is an interesting one because we aren't specifically arithmetic. If we were to wear arithmetic, we would have to be an integer or a float or something like that. But we aren't, we don't have any value at all. So what happens here? Well, there's another rule apparently. So I is 0 here. And it also is, oh yeah, sorry. This is the constraint that I was talking about. So a declaration shall declare at least a declarator, and that doesn't happen here. But there is another rule apparently, which is a new feature. In C89, all type specifiers could be omitted from the declaration specifiers in the declaration. In such a case, integers were implied. So we know that our I is an integer. And because of this rule, we also know for sure that this integer is 0. So that's our starting point. This line of code starts with an integer being set at 0. Okay, that's a good start. It's great, we know, but it's only the first 2 bytes we have explained right now. If you were to make sure that this line was working, you also have to use this in your when compiling this line of code. By using this, you use the C99 standard, which makes sure that you start with an integer if you don't use a declaration. So that's the first 2 bytes. Now we have a bigger problem. We have a function here, the function f, and the function f has no return type and also no arguments. And yet, if we look in the function type, we see f calling itself. It's a recursive function. And this function actually uses arguments, which we don't have. So that's an interesting thing to look at. And also we see it never returns. So that's also something to look at. So those are the 2 issues we're dealing with right now. And we'll start off with the first one. If we look at the function itself, we see that the beginning of the function uses -i, which means extract 1 from I. Let me go to the next slide. Thank you. So we started with I is 0 on the first line, as we explained earlier. And now we make I -1. So that's our starting point, -1. And it's important to know that in C, only 0 is false. So every other number is true. This means -1 is a true number in C. So this is true. And to understand what impact this has on the rest of the line, because I isn't used anywhere else, you have to know how short circuit evaluators work. Okay, I'm sorry. We're going to start with why the arguments work. So we see that f has no arguments, and yet f uses arguments in the line itself. So what happens here? We look at a brief example, which is this one. And in this example, we have a function f, which takes no arguments, and we have a main function which calls f with an argument, which is a function. And if we were to compile this and to run this, we see that it actually outputs hello world first and then bye world. This is what the output looks like. So if we look back at the code, we see that the hello world is called first, which means that the argument inside of f, the printf, is run before the function itself. So that's an important one to know. So apparently in C, you can use arguments even when there are no arguments expected for a function. This works for all functions. Of course, you don't always want this. That's something important to remember. It's not a behavior that you would expect. So you can actually make sure that it doesn't happen by giving f an argument void. If we were to declare f like this, we wouldn't have this problem at all. So that's an important thing to know. But we didn't, so we can use the structure that we used earlier. So this actually works. So every time we call f sleep 7, we sleep for 7 seconds. Okay, so that's great. Still doesn't explain why this function sleeps for 1,000 years, but we're getting closer. And that's where short circuit evaluations come in play. So a short circuit evaluation is a small trick to make sure everything runs as expected, and to make sure you don't have to use if statements everywhere. So if the first part of the short circuit evaluation is false, then the second part doesn't have to be evaluated, because of course the whole statement already is false. So there's no reason to evaluate the second part. So whatever is behind the two end signs isn't called at all. So that's the reason the sleep isn't called eventually. So when does this happen? That's the ultimate question. Well, the first part has to be false to make sure that the sleep is never called again. For that to happen, we need to have I is 1. Because if I is 1, minus I will eventually result in 0, and the first part of the statement will be false, which means the second part won't be evaluated. And then the sleep won't be called. So that's what we need. Now we know why everything works like we wanted. We can calculate whether this solution actually works. And for that, you have to know that the I is standard assigned 32 bits integer. I'm cheating for a little bit because that isn't always true. There are some ways to get around it. Oh, sorry, I missed a question, which might be interesting to answer right now. Just void arguments or any type? Oh, okay, I see it now, Mattis. Just to answer it anyways now we're busy with it. All functions, so yeah, all void arguments. That would mean that if you wrote a function that returns an integer, the function itself would still be called, but there would nothing to be done with the return. Okay, back to the presentation we're doing right now. So I is assigned 32 bits integer. That isn't the case in any situation. You could, of course, compile this on an older computer or a computer with another type GCC, and then it won't work, but we're assuming 32 bits right now. We're also assuming integer overflowing, which is a very important part of the solution, because right now we're starting with situation I is 0, and we're immediately going down. So the first thing we saw was that I was going to I is -1. And now we're counting down every time. We're sleeping 7 seconds, we're decrementing 1 from I. And we're going to the minimum value, which is minus whatever this value exactly is. Then we wrap to the other side. This is for GCC, it's standard behavior, but it isn't standard behavior for C. The standard defines this as undefined behavior, but most C compilers will automatically wrap. If you want to force this, you can use minus f wrap v as an argument for GCC, and then this behavior will be the standard behavior. So what we see right now is that we have 2 to the times 32 values here, minus 1 actually, of course. And if we were to calculate how many seconds it were, we get the calculation as below, and eventually that will result in 952 years and 7 seconds, comma 7. So that's the reason why this function works. I hope it's clear, but otherwise please ask me in the questions or check the version I wrote down. And then we'll go to the second one, which isn't this technical. It's actually more of an explanation of how we used to do things before modern times, because C is a bit older than we are. And that's a simple question. It's just this question. We start with an integer A, and this integer is declared as 0. So no quirks, just normal integer. It's 0. Then we have a comment, and then A++. The question is, what is the value of A after running this? Because of the way I ask, you probably have a clue that it won't be 1. The question is, what will it be? Well, it will be 0. But we'll get into it why. And to start off with that, we have to know a little bit of background information. So what happens here? Well, this is the table of characters we used before modern keyboards. And there are a few keys grayed out. And these keys are important, especially these keys. These are the keys that are included in this character set, but they are language specific, which means that the following line of code will be written down by a Swedish programmer like this. Well, at least that's what I thought, so I wrote this down on my blog, and then a Swedish person came to me and explained to me that it had to be actually this. So this is the line of code that we need right now. So this is what a Swedish programmer reads back in the days. And of course, if you have a whole code, it's impossible to work on this. So the C standard came, or the C committee came with a brilliant solution. We just replace all of these characters. Super useful. And they call it trigraphs. So these are trigraphs. There are, I believe, 10 of them. So I'm counting them. Okay, 9. So there are 9 trigraphs, and the combination at the left is the equivalent of the character on the right. So all the characters that are language specific can also be replaced by this combination with question marks. So very useful. It's super ugly and it's hard to read, but it's a solution, let's be honest. For C++, there was a lot more to replace. So eventually, with the C++ diagrams and all the tokens, this was the result that was to be used. Okay, the trigraphs are to replace the characters. So they have to be replaced before anything else in the code. So the preprocessor will replace them. That means every combination of question mark, equal sign will be replaced by this hashtag and etc. Okay, this is important. Important to know is that it's now disabled, luckily, but you can still enable it. But it used to be normal behavior. And the result was that our line of code results in A is 0. And to understand that, we look at another example here. So this line of code will actually be translated like this. And as we know, this is a short circuit evaluation. So this is the result. It's a normal statement. There's nothing weird about it. It can get weird if you realize that the preprocessor is the one handling it. which means that will be handled before anything else. Okay, let's go back to our example. So this is our question. Which characters will be replaced here? Do you have any clue? Okay, well, I will tell you. The last characters in the line will be replaced. So it's a question mark, and the slash. And this will be replaced by the backslash as seen in the table at the right. So this will look like this. Still not a huge problem. But does anybody see what the problem about this line of comment now is? The backslash has still to be evaluated, and the backslash will eventually, I see chat message coming in. Exactly, the backslash will how do you say it? Will cut out the new line that will be escaped. So we'll get a++ on the comment line. It's never evaluated. This doesn't seem like a big deal, but imagine we had an if statement behind this. The whole if statement would be put in the comment line and the code block will always be run, for example. Nowadays, you have to enable this. You have to put a /w trigress in the GCC arguments, but it was standard behavior in the GCC compiler. Well, I was asked to keep this short, so that's what I did. It's actually all I have, but I wanted to end this with a short comment of the C committee about trigress to remind you to never do this. Thank you.
All right, thank you, Robin. This was really interesting. If anyone could unmute and give Robin a clap, that would be great. Let's try this.
I don't think my mic's picking this up.
It is.
Oh,
Yay!
cool.
Wonderful.
Thank you.
It's almost as we're in a physical space all together. All right, so I saw some questions. So if anyone wants to ask something, please unmute and just shoot your shot.
I'll look back to see which questions I missed.
Yeah, there was something answered by someone else.
Oh, nice, thanks.
Yeah, so there's discussion.
I am interested in how Rust handles this because Rust is known as something that solves all the problems C has. But it's important to realize that these aren't real issues. The C committee did this on purpose. Now they regret it, and most of it has been disabled nowadays. But this was done on purpose. The default expected behavior doesn't exist indeed. Yeah, well, it was sort of answered indeed. There is no default behavior. So the C standard isn't very clear about that. There are a lot of cases that have to be handled by the programmer. And if that is not the case, then the C standard expects the compiler to handle it. And the standard behavior of the compiler is to do whatever the fuck he wants, as they say it themselves. Not my words. Well, now it are, but whatever. So you can never rely on your compiler to do things the standard way. Once you do things that are unexpected, you should expect unexpected results. Do not comment your C code. Yeah, that's a great solution. Thank you very much. Well, I do agree with you that C code should always be, it should, for the biggest part, explain itself. Otherwise, I think you've written bad code. Of course, not everything can be explained by itself. You should make comment names, or you should make variable names that are comments. That's not the solution. But if your function's too hard to understand, it's probably too long to be a function.
Okay, hi Robin, it's Roman here. I have a question. Hi. Yeah, so I had a question regarding the first exercise. So was there any particular reason why was to go like into negative first and then loop back to positive, and not the other way around, or just like, yeah, it's done like this and for no particular reason?
I do remember that there was a reason. The first version, because this version has been rewritten multiple times, the first version actually did go into the positive numbers. I believe it spared 1 byte, but I'm not sure why it did. It was a semantics thing. It's not very important. You could, of course, go into positive numbers and then you would have the same result. Okay. There was a small trick which made it a byte smaller, I believe.
Interesting. Okay.
That's also the reason why the function sleep was put into the f function, into the argument actually. The first version put it outside of it, but they could spare a semicolon by putting it in. Are there any more questions?
Yeah, I had a question. Why specifically sleep for 7? I think I saw right. Was that just an attempt to target a round number of 1,000 years? Or
yeah. The question was very specific about 1,000 years with a 10% margin, but this is also something which wasn't in the first version. The first version didn't sleep for 7 seconds. I believe it was 14 seconds the first time, and this was also the result of optimizing. The first version actually was 40 bytes and used a for loop. And eventually we came to 24 bytes in the version you saw. So there has been a lot of removing and rewriting them. Yeah.
All right. So does anyone have any other questions? Because I was about to ask Hector for a comment, because I think we will forget about these questions after the break. So if you have any idea about Rust?
So what would happen in Rust? If you try this in debug mode in Rust, it will throw an exception. If you hard code your numbers, it won't even compile. But if, for example, take your number from an input, it will throw an exception and fail. If you run it in release mode, by default, it just wraps around back to the positive. But you can enable that, of course, in the configuration files to also check for overflows in debug mode. So that's what Rust does with overflows.
Just overflow to the maximum positive number.
Yeah, in release mode, it's by default overflows. If you disable it or if you run the debug mode, it will catch it and throw an error.
Cool.
Nice. All right, last chance for questions, and then we'll do we'll say thank you, and we'll do a 5-minute break. Anyone else? Okay, wonderful. So thanks a lot, Robin. It was interesting to say the least, and I hope I'm speaking for all of us here. Thanks a lot. All right, so let's do a quick break. We're gonna do it for about 5 minutes, and I'm gonna see you guys back here in just a few seconds. Go get some hot cocoa or something. All right. Let's get moving. Is everyone here? If I could see some faces, that'd be great. Don't feel forced, but would be nice. Yeah, Hector, if you want, you can also unmute, but I'm gonna give you just a quick intro and then you can start. So welcome back, everyone. This is going to be the second part of today's event, and it's going to be about Rust, the criminally underrated language, you know, the wonderkind, something that I myself I am very interested in, and it's an interesting initiative, and we have Hector here to talk about it, and he's done quite a few projects in Rust, and yeah, I hope you all enjoy. Take it away.
All right, welcome everyone. Let's share my screen. Is it visible?
It is visible, yes.
All right, perfect. So welcome everyone. I'm Hector, and today I'm going to be giving you a quick introduction to the Rust programming language. So first of all, I want you guys to meet Ferris the Crab. He's the unofficial mascot of the Rust programming language, and he'll guide you through all your Rust adventures. So now that the most important parts are out of the way, let's actually get started. So what is Rust? Rust is a systems programming language developed by the Mozilla research team in 2010. And it's mainly used for high-performance applications like CLI tools, web service, games, everything that requires fast execution times. So why would you use Rust? Well, Rust has quite a few advantages over other languages. First of all, like we saw in the previous talk, Rust has, well, unlike we saw in the previous talk, Rust has no undefined behavior, or tries to minimize the amount of undefined behavior. And it also has no garbage collection. C or C++, for example, has a more manual way of managing memory, while on the other hand, you have Java and JavaScript, Python, who use garbage collection. So if an object goes out of scope, or it isn't used after a while, the garbage collection will free the memory. But this, of course, takes a performance hit. Well, Rust uses a different system, which keeps track of the object's lifetime and the ownership of the object, to, at compile time, determine what objects can be freed when. So it's as fast as manual memory management, but it's as easy to write as garbage collection. But of course, that means that the compiler will throw a bit more errors at you if you make a mistake regarding lifetime or ownership. Luckily, Rust has really helpful compiler errors, some of the best I've seen. So it gives you an explanation what you did wrong, a possible solution, a link to the documentation to try and solve your problem. Rust also has a package system, a bit like NPM for Node, and great documentation. And because of the way the compiler tracks ownership and lifetime throughout the compilation process, Rust also guarantees memory and thread safety. So it's really easy to convert your code to a multi-threaded application. And of course, Rust is open source. At the time of making this presentation, the repository has 133,000 commits by over 3,000 contributors. So that's quite a big achievement. So Rust is meant as a very efficient language. So let's look at some numbers. Here we have the TechEmpower Benchmark. It's a benchmark for web frameworks. And in this case, they tested 424 different frameworks, which they developed a simple API with each of them and then benchmarked them all separately. So as you can see here in the top 5, 3 of them are Rust and 2 others are C++. So this shows that Rust is quite a good competitor for some older languages like C or C++. But of course, there are some things to keep in mind. Rust is a relatively new language, so you might encounter some bugs in the compiler. Those are never super problematic. Your code won't break, but you might, for example, get a recursive error log, which spams you with a bunch of errors. But this rarely happens. An advantage of being a relatively new language is that all the libraries and other supporting code that's been written is up to date with modern research and standards. So, for example, the regex library for Rust is one of the best out there. Rust, however, has quite a steep learning curve compared to other languages, since it uses a different way of managing memory. And you will get into fights with the compiler while programming, since you think your code is valid, but for some reason it isn't. But luckily, you get helpful errors to explain what you did wrong. And compared to GCC or Clang, the Rust compiler, Rust-C, is still relatively slow. However, the compiler speed almost halved since 2017. So we're making good progress. Let's look at a few basics of the Rust syntax. So here we're going to first create a new project. So I create an empty folder called Rust Showcase. And there use Cargo. Cargo is the package manager. It creates your projects, it builds, it tests, it does everything for you. So we call Cargo init to create new projects, and then Cargo run to compile and execute our application. So as you can see here, this is basic hello world, which is great for you. So let's have a look at the code. Here we have a function main and a call to println with text hello world. As you might notice, there's an exclamation mark here. That's a macro in Rust. We'll get into macros a bit later, but it's basically a way to have functions with a variable amount of arguments, because by default, Rust doesn't support that. But these macros get at compile time converted into other code. Rust also has quite a lot of default types. So we have signed and unsigned integers. So when you declare a new variable, you start with let, you give the variable name, a colon, the type, and then you can assign a value, or you can do it later. So there are signed numbers from 8 to 128 bits and unsigned numbers from 8 to 128 bits. Rust also has Boolean values, of course, and we have two types of float, F32 and F64. There's also, so we end with the print statement. Rust also has tuples, which is basically a collection of multiple primitive types. So here we have a tuple which contains a signed 32-bit integer, an unsigned 8-bit integer, and a Boolean. And they can be assigned in the same way as you declare them by using parentheses and giving them values. You can access each separate value of a tuple by using the .0, .1, .2. That's a bit annoying to keep track of what's what. So you can also deconstruct a tuple. So here we create a new tuple with values 14 and true. As you can see here, we don't specify the type, since we can let the compiler figure it out himself. And if he isn't sure, he'll ask you to give the type. But right here, it's very straightforward. It's an integer and a Boolean. So as you can see here, we can also deconstruct the types back into two different variables. So we can deconstruct this tuple into A and B. So A will be 14 and B will be true. And we can print them again here. These curly brackets here is a bit like the printf printing. It replaces every pair of curly brackets by the following variable in the arguments. So print first A, then space, and then B. Arrays. Let's look at a simple example of arrays. So here we create an array which contains the numbers 1 to 6. We want to sum them, so we create a variable which starts at 0, and we're going to loop over all values in the array. So here we use the for value in syntax. So we loop over each value in the data array, and we use an ampersand here because we want to. Right now, the owner of the data variable is the owner of the array is the data variable. Right here, we temporarily want to take ownership of that array, so we can get the values out of it. And then after the loop is finished, we want to return back the ownership to the data variable. So here we borrow the data, this array, to iterate over it. And then we add each value in the array to the sum, and we print out the sum. So let's run this. Oh no, we get an error. Let's see what helpful Rust errors, what a helpful comments the Rust compiler gives us. So here it says we cannot borrow sum as mutable, as it's not declared as mutable. We also shows us where in the code it happened. So here we cannot borrow as mutable, and it gives us a possible solution. So consider changing this to be mutable. So by default, all variables in Rust are immutable, so you can't change them. It's also another way to try and prevent bugs during development. So if we want to change a variable, we have to specifically mark it as mutable. So here we change this to a mutable sum, and then we can change it and print it. So if we execute this, we get a result of 21. So structs. Structs is the way Rust handles larger collections of data. So here we have a struct car. It contains an integer, an unsigned 8-bit integer for the amount of wheels. I hope there's no car which has more than 255 wheels. And a Boolean which contains the value if it has a roof or not. And then a few strings. Rust has two different types of strings. We have the string with a capital S and str. str is a reference to a string. And the string with a capital S is an own string. So here own string is owned by the car struct. So if the car struct goes out of scope, own string disappears. Static string is a reference to another string. So it the card can be destroyed, but the string itself might still be alive. The problem, however, is that we have to give it a lifetime, since we have to know for sure that the static string lives as long as the car. Because if a static string goes out of scope before the car does, then this variable will point to some invalid memory. And that's exactly what Rust wants to avoid. So right here, we give it a lifetime. In this case, it's static, so we'll just live for the whole application. So if we want to create a struct, we do it using this syntax. So we give it the type and curly brackets, and then we fill in all the fields. So if we want to create an own string, we do use string from, and then pass it a normal str type. And the static string, we could just give it a static piece of text. This piece of text is static because it will just get compiled into the binary. So we are sure it will never be freed from memory first and then the car, because that would mean invalid memory in this variable. We can also print all the fields like here. If we run this, we get what we would expect. The car has 3 wheels, it doesn't have a roof, and then hello and world. Next are enums. Enums in Rust are very powerful. In most languages, enums are just a choice. So, for example, a difficulty, easy, hard. But Rust enums can also can contain data. So right here we have an enum, which is an IP address. As you might know, IP addresses have 2 different versions. There's IPv6 and IPv4. And an IPv4 address is made up of 4 bytes, while an IPv6 address can contain is best represented as a string in this case, to keep it simple. So here we create an enum IP address, and we have one variant, which is IPv4, which has 4 bytes. So in this case, for example, 192.168.0.1. And when we have another variant, which is version 6, and that might contain an IPv6 address. So if we want to create these separate versions, we do it like this. So we don't have to specify the type. The compiler will figure it out himself, do IP address, and then version 4, and we'll give it all the different variables. The same here, we will give it a string. But how do we use these enum variants? So for that, I made a print function, which takes in a reference to an IP address. And then we have the match. Matches in Rust are really powerful. It's a kind of a switch statement. If you come from JavaScript or Java, but they get compiled into extremely efficient code. So right here, we have an IP, we have a match. So we check what the type of IPs. If it's an IPv4 with variables A, B, C, and D, we print IPv4 with A.B.C.D. These 4 variables will correspond to the first, second, third, and fourth byte. That's also why we don't have to give these a name here. We can just give them a name while actually using the values. The same for version 6, we give it a value. This will correspond to the string, and then we can print out IPv6 with the value. So if we run this, we do what it does what we would expect. So we print the IPv4, and then we print the IPv6. So these enums can be used for a lot of different things. They're really useful when, for example, parsing HTML, or you can specify an HTML node as an enum, or a lot of different other applications. So next we have functions. Rust is kind of an OOP language, if you look at it that way. We have structs, and we can attach functions to the structs. So we kind of have objects with functions, but it does not have inheritance. But this is a basic example I set up with a battery. So here we have a struct battery, and it has a charge. So it would be nice if we could say battery.charge or battery.discharge. So first let's create a function to create a new battery to make it easier to construct one. So all the functions relating to this battery object will place inside this impl battery, so the implementation of battery. And you have a function new. It takes in the battery charge as a 32-bit float, and it returns self. In this case, self corresponds to the battery here. And this function will return a battery with a charge of battery charge. As you can see, we don't have a return here, or a return keyword, since in Rust, if your last line is, on your last line you leave out the return keyword and the semicolon, to automatically see it as a return. So this makes it just a bit easier to read. So this will return a new battery. But what if we want a function to act on a specific instance of a battery? So for example, here, as we use it, battery.print, we have to access the fields of battery. So we do that by, in this, for example, in charge, taking in a reference to self. So this is a reference to the current instance of battery. And we make it mutable, since we want to change one of the fields of the battery. So we want to change the charge. So we take in a mutable reference to self and the additional charge. And then in the code itself, we increment the charge of self, which is the current battery instance, by additional charge. We do the same work for discharge, again, a mutable reference. And then we have a print function, but this one does not take in a mutable self reference because we don't change any values here. We just access them, so they don't have to be mutable. We can then use this code we wrote by, first of all, creating a mutable battery. Since we want to change the charge, we have to make it mutable. So we get a battery, new, and we give the starting charge, which is 0.5. So I will call this new function and set the charge to 0.5. And we can print it. We can charge the bit, we can print it again, discharge, and print again. So here we should see the battery start at 0.5, increase, and then decrease. If we run this, as you can see, we start at 50, go to 64, and then go to 29. So then there are traits. Traits is a way of implementing common behavior between different types of structs. So let's make a trait print. You have a trait print, and it's kind of like an interface in for example, Java. So we have a function called print, and it takes in a reference to self. So each object which implements this trait should have a print function. So let's start with a struct cow, and has an amount of milk it produces per day. And then if we want to implement the trait print for cow, we write impl print for cow. It's pretty straightforward. It almost sounds like English. And then we have the function print. In here, we can use the self-reference to access the milk per day. So in this case, we just print out I'm a cow and I'll produce X liters of milk. We can do the same for a human. So here we have a human with shoe size, and we implement a printing trait for human. So we need to make sure we have a print function. Now we can print I'm a human with shoe size Y. So if we don't want to use this code, we can, for example, here create a new cow, create a new human, and call print on both of them. So if we run this, we get I'm a cow now produce 12.5 liters of milk, and I'm a human with shoe size 45. This is a pretty basic example with traits, but the trait system is, well, the standard library of Rust and the whole language is littered with traits. If you, for example, want to make your own mathematical types like a vector, and you want to implement the additional operator, so a plus, that can be done using traits. So you would implement the add trait to your struct. And that's the way you can, that's the most common way you interact with the programming language and extend your code to make it more user-friendly. So now we've seen the basics, let's talk about Cargo. Cargo is the package manager, project builder toolbox of Rust. It basically does everything. It can be used to check and build your code. So checking only checks for errors. Building also compiles a final executable. Check is what's used by your IDE to show the red squiggly lines underneath your code. It can also be used to run and test your code, to update your dependencies. So dependencies are handled on, well, they can be found on the site crates.io. In Rust, the dependency is called a crate. And it's really easy to add a dependency to your project. As you can see here, this is the page of Rocket. It's a web framework used for building APIs. And you can use this single line of code here, and you add it to your cargo.toml, which is the configuration file. And then you can use your library inside your code. You probably tried using libraries in C or C++. It's a bit more complicated. So that's, again, something that Rust tries to make easier and less error prone. And last, we also have Clippy. Clippy is your personal Rust assistant. It's basically code analysis and style check all combined. So it will give you suggestions on how to improve your code. If you could, for example, use wrong naming conventions, or you're copying some data, if you could just borrow it, which is a lot more efficient. Clippy will warn you, give you possible solutions and links to documentation. So Clippy is really useful when you're just starting out to write proper Rust and use all the features Rust provides. So let's look at some actual more complex code examples. So first of all, let's start with the classic FizzBuzz. So this is FizzBuzz in Rust. So we have a function main, and here we have a for loop, which loops over all numbers from 1 to 100. This in Rust is called a range. We'll iterate over each number in this range. And then we have a match. Like we saw in a match before, a match cannot only work on normal variables, you can also use tuples. So in this case, we create a tuple with fields I modulo 3 and I modulo 5. So if I is divisible by 3, this will be 0. The first variable will be 0. If I is divisible by 5, the second variable will be 0. So then inside our match block, we first check if both of them are 0. So if it's divisible by 3 and by 5, we print FizzBuzz. If it's divisible by 0, but not by 5, this underscore is like a wildcard for all other possibilities that are not in the match. So in this case, the only things in here are 0, so it's everything that's not a 0. Then we print fizz. If it's the first one is not a 0 and the second one is 0, so it's not divisible by 3, but divisible by 5, we print buzz. And if it's none of them, we print the normal value. So if we run this, we get the normal FizzBuzz. I trimmed this down to 20 entries, otherwise it would be a bit too long. So that's FizzBuzz. Next, there are optionals. Optionals in Rust are, again, very much incorporated into the core language. So since we saw before, there can't be any references to invalid data. You can't also have pointers to non-existent data. So there's no way to represent data which doesn't exist, so like null or undefined. That's where optionals comes into play. So as you can see here, we create we have a basic example with optional. So here we have a square root function, and it might return a number, but it might also not return a number. So if the number is negative, we want to return an invalid value. So that's where an option comes into play. An option is an enum, which again shows the power of these enums, and it's either none or it's some value. So in this case, we have square root, which takes in a value x and returns an option of a 32-bit float. So if x is smaller than 0, we return none, since then we can't calculate the square root. But if it's bigger or equal to 0, we return some, and we get past it the value of the square root of x. So this is again an enum type, so we have the enum variant sum of option, and return that, otherwise we return none. So now if we want to use this, we create a new variable, result, assign it to square roots. But the type of this variable now, it's not a float, it's an option of a float. So we can't use it to do other calculations. But we can use a match to check its result. So here we match on result, and if it's some value, we print the value. If the square root function returns an option with a non-value, we print the square root result is none. There are also other ways to get rid of the option and just get the value, which is unwrap. But unwrap, if your option is none, unwrap will throw an error and will fail. If it's some, it will just get you the value from inside the option. So in this case, we're taking the square root of -9. So we'd expect to see that the result is none, and this one should then technically fail. So if you run this, as you can see, the square root result is none, and we get an error. The thread panicked and called unwrap on a non-value, which is not allowed. So those are options. They're used throughout the whole standard library for reading files. If a file doesn't exist, you'll get an option with none. Reading input, parsing text into numbers. If it's not a number, it will return none. All of those things. So let's now look at a live coding example. Let's see. So we're going to use the Rocket framework I talked about earlier to make a very simple API to just return hello world. So Rocket uses quite a few macros to make the coding easier. So this is a good example to see the power of macros. So let's create a function. So function hello, and it will return some piece of string. Again, we're going to make this a static string since it will never change. It will do return hello world. In this case, we can also leave out the return since it's not needed. So this will be our handler for this request. Now we're going to use Rocket, and Rocket has a lot of useful macros defined. But if you want to use them, we need to import them. So we'll do and we now specify which crate we want to import the macros from. And this crate is called Rocket. So extern crate. So now we need to mark this function as a handler for request. So we can do that by using one of the macros, which is get. And then we need to give the path we want to use. So hello. As you can see, it still gives us an error. So if we look here, see that macro is experimental. These type of macros are still in experimental phase. So we need to enable them specifically. And it's as easy as adding a single line on top. So we want to enable feature. And the feature is, so now we don't have any errors and our code should compile, but it won't do anything because we didn't change the main method. So for Rocket, if you want to start your application, you first have to create Rocket. So we'll do Rocket ignite, that will start our Rocket. And then we can use all configuration, and we can set settings and configurations, which we won't do right now. But then we can do, to actually start, we can use launch. So this should create the default Rocket and it will launch it. If we run this, the car will run. It won't do anything, but as you can see, these are configurations and our Rocket has launched. If we go to a web browser, it won't do anything because we didn't set up any routes. So we can add our hello function by using mount. So mount will add our hello function to the Rocket. We have to give it a path again, so we'll just mount it at the base path. And then we have to give it a list of our handlers. Luckily, there is a macro for that to easily create a list from our single hello. So we do routes and hello. So this should now compile and give us one API input. So if we run this, as you can see, we got a message here mounting hello. So if we go into our browser and go to hello, we get hello world. So that's a basic API route. Let's make this a bit more personal and get a personalized hello world message. So we can take in a name here. As you can see, if we don't do anything with this, we get an error. It's an unused dynamic parameter. This shows you that the macros are properly checked and compiled. So if we don't take this as an input to our function, our code just won't compile. Again, another way to prevent bugs at compile time. So we'll take in a string name, and then we want to make a personalized message. So we'll use the format macro, which is kind of like println, but instead of printing to the console, it will return a string. So we'll do format and we'll give it hello and the name. Now format returns an own string, so with a capital S instead of static string reference. So we'll just change this to an own string. So if we rerun this, you see we got a rooted hello and a name. So if you go to hello, this doesn't work anymore. But if you add a name, Bob, we get hello Bob. If you change to Frank, you get hello Frank. And the final thing we're going to do is going to make this even more advanced, and we're going to add some simple JSON show serialization. So instead of returning a normal string, let's return a struct. So we're going to create a struct message, which takes in, which has send, and the contents, also string. I would like to return this in the hello function. We can't just return struct, we have to return a JSON value, which is part of, oh yeah, I'll show you the configuration of the project. So here, this is an example of the cargo.toml file. This is a configuration of the whole project. Here in the name, the version, authors, edition. And here we have the dependencies. So we have Rocket, which is the web framework. We have Rocket Contrib, which has some extra utility functions for example, JSON. And then we have Cerde. Cerde is the most popular serialization library for Rust. So we'll use that to convert our structs into JSON. So here we want to return some JSON instead of a string. So we're going to do normal import, and we're going to import the JSON value from Rocket Contrib. JSON value. So now our function can return a JSON value. This format we won't need it anymore. So let's construct our message here. Well, first we'll construct the contents. So that contents is format, and then we'll do the message. So that's the message. We'll set the sender to the name, and we'll set the contents to the contents. Another small useful feature is if the struct variable name and your actual variable name are the same, you can just leave out one of them, which again makes it a bit easier to read. So now it would be perfect if you could just do return message. So, well, let's learn how to type first. Unfortunately, that won't work since we're expecting a JSON value. Well, like you might have guessed, there is a macro for that, convert to a JSON. That's a macro from the Rocket Contrib package, so we'll import that one as well. And here we can do JSON. It will convert message into JSON. Now it looks fine. We don't have any errors anymore. So let's run this. And as you can see, there's still one more problem. Let's make this a bit bigger. Yes. So here, the trait-bound message serialize is not satisfied. So the trait serialize is not implemented for a message. Well, for a message to be serializable, it has to implement the serialize trait. While we could do that ourselves and manually serialize those both fields, luckily there's a way to do it automatically and generate at compile time. That's derive. It will generate the default implementation for a specific trait, and we'll do serialize. We also need to import this one. So now this line will automatically generate the serialization trait for the struct message. So this error should now be resolved. So if we run this, as you can see, it launched. We have our root mounted. So if we try this again, now we get back some JSON data. That's pretty print. All right. So this is a very basic example of one of the most popular web frameworks. Of course, there are way more advanced features, but for those we don't have enough time. So let's continue. Can I make this full screen? Yes. So where is Rust actually used in production? Lately, a lot of companies have been adopting Rust. One of the ones you might know best is NPM. NPM has been adopting Rust for its backend since they have so many downloads, and it needs to perform very well while still being safe, and it can't have any memory exploits or something, because that would be quite bad. Of course, Firefox also uses Rust, since Rust was developed started by the Firefox Mozilla research team. And they wrote Servo, which is a browser engine. And once features in Servo got good enough, they have been merged into Firefox. So now there are several features in Firefox which are written in Rust. Microsoft also announced that they were going to add, they were going to write certain parts of their Windows 10 operating system in Rust. However, they did not say what exactly. And there have also been a few requests to merge Linux kernel code written in Rust into the kernel. I don't think they've been merged right now, but I don't think it will take that long, since Rust is perfect for example, operating systems, since it guarantees memory safety, and most bugs in operating systems are related to memory overflows or memory exploits. So that's a perfect usage of Rust. And also other big companies like Dropbox, Postmates, and Sentry, the logging platform, all started using Rust. So then there's also this other cool thing, which is, are we X yet? So this is a collection of websites, and they show you the progress of the libraries from certain fields. So for example, we have RB WebYet, which shows you all the web frameworks. And right now, the RB WebYet website at the top shows, yes, we are, and it's freaking fast. So if you're not sure if Rust is suitable for a specific field, you can always check these websites and show you a list of all frameworks with a bit of information. There's also RBGUI. That's, in my opinion, one of the most lacking fields in Rust, GUI. There are quite a few frameworks. These are a few of them here, as you can see, but they're all still quite young. But there are, of course, bindings for frameworks like Qt or GTK. There's also RB AudioYet, RB GameYet. That's not a big one. Game development, game engine related projects. And there are quite a lot of them. Recently, there's a new game framework has been released, Bevy, and it looks really promising. There are already quite a few people using it to make production quality games. And there's also RB LearningYet for machine learning and RB QuantumYet for quantum computing, which is really fascinating. So why would you use Rust? Well, Rust, first of all, is something different compared to a lot of other languages. It uses a different system of handling ownership on lifetime. So it's fast while easier to write, less hassle-free. You don't get thread or memory errors. They have been handled through at compile time. And above all of those, it has a modern syntax, so it looks really clean. Rust also has what they call zero cost abstraction. So there are things like you can, for example, sum all values in a list really easily by one line of code, and it performs as fast as writing it manually, which again makes it quite broad and easy to read. Then there's a package system like cargo and documentation. Documentation is really, really nice. There's the official Rust book, which takes you from Rust beginner to advanced Rust programmer and explains everything. And the official documentation is also really well structured and clear to read. I don't know if you guys tried to look something up about C or C++. That can sometimes get quite confusing with all the old relics and scrolls containing documentation. And one of the most important things, Rust has a great community. If you ever try out Rust and you're stuck on even some of the basics, feel free to ask on the forums or the subreddits, and someone for sure will help you out. Everyone's excited to share Rust with the community. And yeah, there's so many more things making Rust great, but we don't have time for all of them. I recommend you guys try out Rust. It might be one of your next system programming languages. There are a lot of features for you to discover, and yeah, I hope you give Rust a try. That's it. Thank you very much.
Thank you, Hector. All right, second round. Let's unmute. Let's give Hector a round of applause. Everyone who can. Go, 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 go. Right. It's kind of weird. It's kind of semi-muted, but thank you guys for the effort. Okay. I saw a lot of discussion regarding Rust.
Did not follow the chat at all.
Yeah, well, you couldn't. But if you would like to unmute to ask about anything, or actually, so the first question was about a source for the RWYet pages, and I found an entry in the Mozilla wiki, which I think is pretty good.
Yeah, I'll look that one up. Oh, you already have it. Okay, perfect. Yeah, that's the best one. They list, I think, all of them. But I'm not sure if all of them are actually Rust. Yeah, I'm pretty sure all of them are Rust. Yep. Cool.
Nice. All right. Questions? Feel free to just unmute. You could also take a look at the chat if no one wants to speak up.
Now, macro time, nice. You mean to implement? Yeah, no clue what you're talking about. I'm sorry, a bit late.
I meant that, like, the way you actually write macros, like if you're at Rocket and you want to write your own macro,
yeah,
writing macro is pretty hard and insane.
Yeah, it's a bit more complicated than the basics of Rust, but it's a very powerful system, and it's not that complicated. But you can do so many cool things with macros. So once you know the basics of Rust, it's quite easy to get into, and you don't necessarily have to write your own macros. You could write it yourself, but just makes life a lot easier.
Hey, Hector.
Yes, hi there.
Nice talk, first of all.
Thanks.
And I have a question about what frameworks we should keep an eye on besides the web framework you showed, Rocket.
Yeah, Rocket is one of the exciting ones. If you're into game development, there's Bevy, which is relatively new. I think it's released 3 or 4 months ago, the framework. That's a really cool one, with quite a few new design decisions. There are frameworks for everything. All the like basic ones like Martijn parsing, regex are all very nice. They're very well supported. Yeah, if you want to discover some frameworks on your own, the Are We Yet websites are a really great source.
Yeah, I saw even like quantum computing is on there.
Yeah,
So,
I myself haven't delved into the quantum computing, but there are quite a few frameworks out there. It looks quite promising.
well, we don't have the hardware yet in our
Yeah.
homes, so it's hard to run code.
Gonna be a bit difficult.
Yep. All right, thanks.
No problem.
It's also worth to mention Tokyo. Like Tokyo is the
Yeah.
runtime running on Rust rather than a framework for Rust, and it's a pretty very insane thing for synchronous runtimes and things like that.
Yes, Tokyo is also a really great framework. It does so much that basically makes async programming a breeze, but it handles a lot more other things as well. So yeah, I wouldn't recommend looking at Rust as a first library because sorry, not Rust, Tokyo, because it can get a bit confusing, but it's definitely something to take a look at. Are there any more questions?
I mean, I had a question about asynchronous programming, but I think you just answered that indirectly.
All right.
Yeah, because I mean, for like web stuff, it's all async.
Yeah. Well, yeah, Tokyo is ideal for that.
I'm gonna paste that in chat if anyone wants to take a look as well.
Why is the battery var mutable? I see that one. Let's have a look. Battery. No, it was a. Where was the battery? Yeah, here. So I think they mean this mutable. If we take it in like here as a normal reference, we can't change this the charge variable. So right here we're changing the variable. So if you want to change it, we have to mark it as a mutable reference. Otherwise, it won't compile. So that's why we take it as mutable. I think that's it question-wise.
All right. Seems to be good. Okay.
All right.
Thanks a lot, Hector, for the talk. Super informative. Hopefully, some of you guys will try Rust now and maybe even contribute to it, or maybe some of you have already. It's definitely a gem, a hidden gem that is very fresh, as Hector has mentioned. So get on for the gold rush as soon as possible, so you don't miss the train. All right. On that note, thank you everyone for joining this event. I hope you've got some value out of it. Thank you again to Robin and to Hector for their excellent talks about systems languages. And I hope you guys keep an eye out on the our Twitters or WhatsApps. And if there's no more questions for either Robin or Hector, we'll be closing this out. So I'm gonna give about 10 seconds for anyone to speak up if they want to ask anything still. All right, and if not, I hope you guys have a good evening. Thanks for joining. Goodbye.